So hi, good afternoon. Welcome to the Parlé microphone optimization. Hope you guys are all doing well amidst the chaos happening in the world. But nevertheless, thank you for tuning into the to this webinar. Whether you are from sales, technical, or an installation background, I hope that you will find this webinar useful in aiding you towards a successful Parlé microphone commissioning. So without further ado, I think we will begin. So I'm Gerald, Technical Projects Manager for the Southeast Asia region. I'm based out of Singapore. And today's topics, basically what we will want to cover is the origins of the Beamtracking microphone family, some acoustic measurement considerations when it comes to Parlé microphones. Of course, the optimization tools that you can utilize, software and on the Tessera DSP itself. And finally, optimizing the microphone performance with a DSP. So a little bit about the beam tracking microphone. The unique shape of the beam tracking microphone actually first started out with Deaf Audio's microcone, which featured 6 recording zones. Deaf Audio was an Australian company acquired by Biamp in 2014. In 2016, Biamp relaunched the beam tracking microphones with the Devio product line. So the initial form factors include the table and the pendant. So what you see over here is, of course, the Devio table microphone and the Devio ceiling microphone. So in 2018, the Parlé microphones were launched for the Tessera family with the table, pendant, and flush ceiling form factors. So you have the Tessera table microphone, Tessera ceiling microphone 1, and the Tessera ceiling microphone X. So each microphone comes with a network box to connect additional microphones. For the X series, the TTM-X and the TCM-X, you can have one additional microphone, and for the TCM series, you can TCM1 series, you can have 2 additional microphones. The TTM-XEX and the TCM-XEX, they can be used with the current generation Devio units. However, you can only utilize one microphone per Devio unit. Oh yes, and I forgot to mention, if you do have any questions, please put them in the chat, and I will try to find time to answer those questions. So the beam tracking microphone, all of these models feature, our beam tracking technology, which forms beams to focus in on the active talker and move with them in the room. So here, for example, you see the talker moving around and the beam follows the talker, ensuring that coverage is still complete. So the Parlé microphones can be utilized in small, simple huddle rooms all the way to large and complex conference rooms. So of course, that being said, which model is the best fit for your application? Now, first, of course, is to consider the floor plan, room dimensions, seating, presenter locations, and of course, the room acoustics. For huddle room tabletop applications, the TTM-X table microphone definitely will fit perfectly in the middle of the table. So it'll feature 4 touch mute buttons. Anyone can, of course, mute it at any point during the meeting. For challenging acoustics, of course, such as high ceilings, then the TCM1 will be at an advantage when, of course, you have to keep the distance to the talker at a minimum. And of course, if the customers prefers, flush mount options, then of course this is where the TCM-X will excel. So all of the models, they all feature automatic LED feedback, which can be controlled in the Tessera software itself. So now, of course, we go into the Parlé mic optimization. So why do we want to optimize? Of course, the end goal is to give an improved experience to the far end to help our clients host successful meetings. And from the start, when we optimize the microphones, we can proactively prevent design problems from being discovered later on. So these design tools will help you to, plot out microphone locations, etc. And thereafter, you'll make the installation and commissioning more effective and efficient. So all the way from sales to installations, members can all contribute to a successful deployment. So our two focus items today will, of course, first be the room assessment and system design. Thereafter, we'll go into system commissioning, which involves the Sierra Forte platform. So when it comes to room assessment, what do we need to know? Well, first of all, the facts that we will have to obtain are the physical properties of the room in terms of dimensions, where we would want to place the microphones, and of course the acoustic conditions of the room. Are the noise levels too high, or is the reverberation time too long? Remember that, of course, poor acoustics due to hard surfaces, excessive reverb, or even poor microphone placement cannot be fixed by a DSP. So in terms of acoustic room measurements, Biamp will actually recommend low-cost Studio 6 digital audio tools, which can be purchased directly from the Apple Store. So the base program, well, last I checked, it was about 20 USD. So this will provide you with the basic SPL and noise criteria measurements. And for the gated noise RT60 measurements, that is an in-app purchase, which last it was about 36 USD. So total, well, 56 USD for a simple app for effective um, acoustic measurements. Yeah, the measurement microphone that you may utilize, of course, together with the Studio 6 digital app will be the digital eye test mic 2. So that is a little costly, going at 230 USD. Yeah, so these are just some of the tools that, of course, you can utilize. But of course, other SPL tools are acceptable, but as long as they have a calibrated measurement. So using the audio tools, you can, of course, take the measurements to assess the acoustics of the room. The first of will be the ambient or background noise. However, this only tells us how loud the room is, but not what makes up the noise or specific frequency component. So we use an A-weighted measurement, of course, which will reflect the closest sensitivity curve of the human ear. Now, when we go into the noise criterion measurement, we take into account how we hear, not like a flat measurement microphone. So the noise criteria measurement will actually help us to understand how background noise will affect the speech, which I will show you just like a small example in the next two slides. And lastly, the RT60 will show us how long the sound energy will take to dissipate in a room by 60 dB. Longer RT60 times definitely will cause poor speech intelligibility. Of course, one of this example is, in a gymnasium or a multi-purpose hall where you may be shouting across to your friend or to your colleague, and on the other side, what they tend to hear is, of course, a drowned out kind of voice. So this is an example of a long RT60 reverb time. So you see in the next slide, what I have here. So of course, when I say light mechanical, when I say mechanical, of course, what I'm referring to are simply vibrations that fall within the frequency range that we are capable of hearing. So you can see here that the background noise is approximately 35 dBA. But then again, what frequency component is causing this? And I think this is where the noise curves come into play. So how we go about determining the noise curve of the room is basically you just look for the highest point from the NC curve. So in this case, it's at the 500 hertz band. So, which is approximately, well, if we just try to follow a curve, so it'll be about 27, uh, noise curve 27. This is still within the acceptable noise criteria range. So typically for conference rooms, it should be between 25 to 35. So this is an example of a room with poor acoustics. So if you can see the highest point from the noise criteria curve, that will actually be at the 1 kHz. So that is giving off a NC rating of 59. Now, this is of course way beyond the acceptable conference room noise criterion curve. And worst of all, you know, they are right in the middle of the speech band. These three frequency components that, of course, I have circled. So in a conference room with these acoustics, the far end may tend to hear unintelligible speech or even digital noise reduction, artifacts, echo, etc. So acoustic room measurements. Uh, when of course we go to any venue and we want to install a conference room system, some of the measurement taking strategy that of course we can take into account is the potential microphone locations and the average talker's location. Of course, these include the seating arrangement. So those circled in red, the seating arrangement and the ceiling locations also. So do take note also that of course in the ceiling there will be loudspeakers and uh, air conditioning. So consider how these might affect the microphone placement or performance. Take the ambient noise and noise criterion measurements at the microphone locations. In this case, a selfie stick would not be a bad idea. And of course, take multiple measurements from multiple locations for accuracy and averaging. So once you have an idea of the room acoustic conditions and the dimensions, utilize our Parlé calculator to help you predict that success. So in this case, I have a ceiling microphone calculator. So simply by keying in the room dimensions and the acoustic setting, the calculator will predict the microphone location and the number of microphones required. The same goes for the table microphone calculator. Um, you just have to key in the room dimensions, the room acoustics, and the table length, in this case for the table mic calculator. So these tools will help you to create and validate the microphone placement and locations within the room. The tabletop and ceiling calculator, they all can be found at support@biamp.com. Design tools, Parlé ceiling mic calculator, or Parlé tabletop mic calculator. So utilize these tools that we have to, of course, help you to uh, design a successful Parlé conference room. So I have a small exercise here. Let's say we have these room dimensions and the acoustic, parameters. So when we reference it to Biamp's room acoustic setting table, which can be taken from the cornerstone, we can estimate that the room will have, at least a good acoustics. So with this information, then what do we do? First of all, I think we decide what microphone we want to utilize. Is it going to be the TCM one, the TCM X, or the TTM X? So I've already done some calculations, which I will show in the next few slides. So with the TCM one, of course, you want to, since it is a pendant microphone, you'll want to set the microphone at a height of about 2.4 meters above the finished floor. And the calculator will decide how many microphones will be required for the room based on the dimensions and the room acoustics. With the TCMX, of course, since it's a flush mount, with the ceiling height set at 3 meters, again, the calculator will determine the number of microphones to cover the entire room. And with the TTM-X, the table microphone, it is simply by putting in the size of the meeting room table, and the calculator will determine the minimum number of microphones. So I've done the calculation already. So as you can see, the calculator will automatically calculate the minimum quantity and the mic placement and how far the microphone will be from each other. However, I want to take your attention to, of course, the TCM1 and TCM-X. Well, if you notice the coverage, they are covering the entire room. Whereas for the table mic, of course, it will just cover the meeting room table itself. Now, what if I only want my microphone to cover the meeting room table, especially for the ceiling mic and especially for the ceiling microphones? Well, we can simply just reduce our coverage. Instead of keying in the room dimensions, we can key in the meeting room table itself. So in that case, the calculator will revise and you'll prevent, of course, it'll just focus it'll just focus the coverage on the table itself. So in this case, for the TCM1 and the TCM-X, you will only require one microphone for the meeting room table. Well, in the case of Group C, of course, I just want to, or rather the tabletop microphone, I just want to ensure that the microphone covers the entire table. So on the calculator itself, you can choose to increase the microphone count. So now we go into the optimizing performance part. I think up to this point, we have been looking at room and the acoustics, but then how do we deal with less than ideal conditions? So in this case, we'll take a look at the DSP and what it can do for us, but also understand what its limitations are. So the DSP, of course, can optimize the gain structure, shape the speech signal for clarity, reduce low frequency noise by filters, and use active noise reduction to remove steady state noises such as air conditioning, etc. The key components, of course, in the Tessera software and with a Parlé microphone will be the Parlé mic block itself and the Parlé processing block. So when you open up the Parlé microphone block, what you will see is, of course, the zone feature itself. So uh, for example, if you have a microphone that is at the end of the room or at the edge of the table, you can actually switch off certain segments so that the microphone will not pick up, for example, reflections from walls or from walls. Yeah. So the triangle that you actually see here, this will actually indicate the front of the microphone as designated by a Biamp logo. So we also have the mute button. Uh, the processing block also has a mute button, which I'll show in the next few slides. So for the next few slides, we'll go through and look about the recommended signal chain for processing the Parlé microphones. So if you don't have Tessera 3.14 yet, we do actually recommend that you do download now we are at 3.15, but the Parlé processing block was actually introduced in 3.14 and it was aimed to simplify Parlé mic commissioning. So using, of course, the information gathered about the room acoustics, we have put in place a single button press, which will load the parameters that are found to be the best practice for a wide range of room types. So from poor all the way to perfect. Although at this stage, I think I want to indicate that, well, if a room has poor acoustics, it will be better to have the room treated for a conference room rather than use a DSP to try to fix the room itself. So we also have a custom option for unique situations once you select any of the room acoustic settings, and when you click custom, the last preset that you have selected will be presented in the Parlé processing block itself. So we'll go into the different blocks in the Parlé processing block and what do they do for the whole signal processing chain. So the first is the digital mic gain, which is an AVB gain structure. So this digital gain block will aim to bring the AVB audio level up to a recommended level depending on the model of the microphone. Take note that if you were to put in a Parlé processing block into the Tessera software itself, the block cannot be altered within this block. So if you are building your own processing chain, then of course you are able to uh, make adjustments for the gain itself. As a recommendation, if you are using the X series, we will recommend about adding 18 dB, um, 18 dB of digital gain, and 12 dB for the TCM1 series. The target of course is to bring the average speed up to 0 dB. So the next block will of course be the advanced compressor. Well, in this case, we have our engineers have kind of like realized that we can use the expander to reduce noise when no talkers are active. So as you can see here, the audio threshold that we have set is around -60, but this can be adjusted as to your room requirement, I would say. So as the intent here is, of course, as the audio level increases, so as speech is slowly introduced, the volume reduction will lessen towards unity, so allowing audio to be passed unaltered. So the idea that the speed that we key in over here will help to reduce the noise that would be previously in between pauses by only allowing signals of significance to pass. So if you are building your own signal chain, we recommend that you can start with these settings and adjust them as necessary for the room. So the Uber filter that we have put in place, well, any equalization of microphone is important for tonal balance. So this is why we have put in the Uber filter. So the high pass filter that we have put inside the Uber filter, you can actually use these to reduce unnecessary low frequencies that do not contribute to the speech intelligibility. Or even you can utilize these to reduce sorry, low frequency noise that is present in the room. And the other parametric EQ can be used to compensate for the tonal preference uh, because of the room acoustics. So the auto mixing block here that we have, it will take into account both the audio signal strength and the microphone beam information to determine the optimal audio sources. So this is kind of where the whole beam tracking comes. I would say the critical block of the beam tracking itself. So if you are building your own processing chain, just remember to ensure that you check this box pre-configure for beam tracking mics, and a BT icon will appear at the bottom of the gating auto mixer. So if you notice that, of course, in most cases, in most of our installs, we actually use the mix output. But in this case, we are actually using the direct output itself. The intention is, well, the idea is to intentionally raise the gain for soft talkers itself. So this is why we use the direct outputs and not the mix outputs. So the last whole function over here will actually determine if all the microphones are gated off when the speech is not present or if background noise is allowed to pass to the far end. This is just purely a personal preference. There are some installs where end user they want a little bit of background noise to be sent to the far end, to indicate that they are still on the call. Again, it depends on the preference of end users itself, whether they would like this background noise, a little background noise to pass to the far end or not, or they prefer complete silence. So when you are using a auto mixer combiner block, which I don't have it here, this is where you will need to use the mix output. But however, since the Parlé processing block does only allows a mix out or a one output, you will actually need to custom build your own signal processing chain to make use of this mix output. So the next block will be the automatic gain control. Now, if you have noticed, of course, that there will be two AGC stages in the signal processing chain for the various microphone types. So the first one will be when you include an AEC block in the Parlé processing. So it is usually best practice that you disable the AEC AGC block and only activate the ones later in the post mixer over here. So as the name implies, the automatic gain control will raise or lower the gain applied to the talker's volume to maintain the ideal range. So what we are looking at, of course, a range of -2 dB to +2 dB. So a soft spoken talker should make the AGC go active as indicated by the green indicator, so resulting in the additional gain shown. If there is instances where the AGC is not adding gain, chances are that the digital mic gain is too low and you would want to um, add increase the level of the gain itself. So the standard mixer block, which is next, simply just combines all of the available audio signals into a single mix, and the standard compressor um, is in place to just catch unusually loud sounds from being passed to the far end. So examples would include volume ramping up to accommodate a soft-spoken talker, and suddenly a loud talker just immediately jumps in. So this is where the compressor will come into play. Other examples will include um, events in a room such as a door slamming. The standard compressor will aim to reduce the noise being transmitted to the far end. So as a start, these are some of the settings that you might uh, that you can actually put into the Parlé processing block and play around depending on the room condition or as part of your commissioning process. So the mute block, the last chain, just will signify the end of the signal chain. The ideal place to actually perform the mute will be this block itself. So why is this so? This is where it will keep all the blocks before the mute active and ready for when the mute is deactivated. So it can be logic driven, as you can see, for linking multiple blocks together, or you can uh, have a third-party controller to control the mute block. So now we'll actually go into a little bit of the Parlé tuning uh, process and how Parlé and the AEC goes together. So, well, as you can see, the most important step, of course, is to set proper gain structure. Then secondly, we will try to adjust the echo return loss, which is the AEC reference itself. So as a start, also, turn off the noise reduction and listen to the space itself, whether aggressive noise reduction is needed or if it's not. Of course, if if noise reduction is aggressive within a room, it will tend to remove speech components to the far end, and it it, it results in negative um, far end conferencing. And last, of course, is to test out one microphone with the talker, of course, in coverage, and once a particular microphone is optimized for far end conferencing, thereafter we copy the settings uh, to the different microphones itself. Last but not least, of course, is to use your ears and have a feel of how the far end is listening to the conversation itself. So for those who are, I'm sure most are familiar with the AEC and its role in conferencing itself. But for those who are new and unfamiliar with it, this is basically a necessity to ensure successful two-way commissioning. So the purpose of the AEC is just to prevent the far end talkers from hearing themselves back through the microphone. So as you can see in this example, the far end speaks, the audio is picked up by the loudspeaker, and the microphone picks it up and send it back to the far end. So which will result in the far end hearing an echo of themselves. So with the AEC engaged, the far end audio that is picked up by the microphone is removed from the return signal through the cancellation. The cancellation will occur in the AEC reference block itself that contains audio from the far end. So signal sent to the AEC reference dictates which signal should be removed from the mic input. And well, this is why we never include room microphones in the reference mix. So key parameter to the AEC canceller working will be the echo return loss, or ERL. This will simply just tell us the difference of the reference compared to the audio arriving at the AEC input. As a start, you would want to, or as a best practice, you would want to keep the AEC reference level about 5 to 10 dB above the microphone audio signal. So as indicated, so a high or low echo return loss values are usually because of improper gain structure. But as we all know, the Parlé microphone gain structure is set by design, and there is no way that we can change the gain of the microphone. So in this case, how do we adjust the ERL values itself? A simple way of will be to adjust the AEC reference level itself. So as mentioned, we are looking for a target range of approximately 5 to 10 dB, and this will be ideal for conferencing. So when it comes to tuning progressions, while generally Parley microphones have an internal high pass filter, using a higher cutoff frequency in the AGC block will actually aid in noisy environments. So of course, that being said, if you notice that inside the Parley processing block that I mentioned in the earlier slides, I did mention that there was also an Uber filter um, that you can utilize to help cut off, reduce excessive noise. Well, as a recommendation, probably what you can do is to use the high pass filter in the Parley processing block for tonal balance of the microphone itself, and utilize the high pass in the AC block So what we have over here to reduce the excessive room noise. So with the microphones itself having a built-in high pass filter of 120 hertz, we can set additional high pass cutoff at 150 hertz for table mics and 200 hertz for ceiling mics. So as most of us would realize that, well, for pods and narrow band codecs, the usable frequency band will be between 300 hertz to 3400 hertz. So we can see that, of course, filter adjustment would be minimal because, well, the usable frequency will only be within this range. However, with newer communication methods such as, well, Teams, WebEx, and Zoom, they support wider frequency bandwidths compared to phone lines. So in this case, it will be a trade-off or a compromise between intelligibility or fullness of the talker itself. So for tuning progression, usually when it comes to noise reduction, how noise reduction works is that it will identify the human speech versus steady state noises, such as your ventilation system. Uh, how it works is, of course, when speech is identified, speech will be allowed to pass, whereas for steady state noises, they are reduced. So in most cases, medium noise reduction are usually sufficient in installs. When high is selected, what will happen is that the noise reduction will start to remove portions of speech. And as such, we I think we will recommend that using high is always a caution, and as much as possible, um, try not to use medium whenever possible. That should be sufficient for most installs. So if noise reduction is negatively affecting the speech clarity, well, we can aim to use equalization to improve the speech clarity itself. So a common area for speech tends to be in the 125 to 500 hertz range. So we can either thin it out via parametric EQ or shelf filters to improve the speech intelligibility. So in some applications, even, we might want to boost the higher range of the human voice. So between 3500 hertz to 5000 hertz, we can, for improve pronunciation and presence. So we can utilize parametric EQ to boost these frequencies. So the next step is to check the automatic gain control. Well, as a best practice, what we will recommend is to mute all other microphone channels except one Parlé microphone in the auto mixer itself. So as a start, these are actually some of the recommended parameters that you can utilize when you are using a Parlé microphone. So if the gain structure is properly set up, so again, gain structure is the most important. So if it is set up properly for a normal talker, what you will hear, what you should be getting from the meter, it should be between -2 to +2 dB. So take note, if you are not achieving this the recommended gain, what you can do is to, let me go back a few slides. Uh, Yep. So if you are not achieving the target of -2 to +2 dB, you can actually increase the gain of the gating auto mixer itself. So the on the input side, of course. Yep. So this is one way that we can try to hit the our target gain level. So once you have achieved that level for a particular single microphone, then you may copy the AGC block and the auto mixer channel settings for the remaining channels. So thereafter, unmute all the remaining channels and verify the performance as the talker moves around the room. So another tool that is useful that can assist in commissioning Parlé microphones will be the non-linear processing. So the non-linear processing, or the NLP, is usually an AEC tool to help reduce residual echo in limited cases where audio artifacts actually persist in the room. In most cases, medium will actually be the default, and uh, that works in most installs. What we have actually observed is that sometimes it is actually correlated to the reverb time of the room. So as you can see that, you know, in a conference room settings, typically if a conference room has an RT60 of, well, more than 1000 milliseconds, they should be treated acoustically before commissioning it as a conference room. So hence in this case, as you can see, a NLP setting of low or medium will be sufficient in most installs. Yeah, definitely it will be a necessity to have a live conference call after you make the adjustments to verify the reduction of the audio artifacts. So at this point, let me just pause and have a look whether there's any questions. Nope. So no questions. Guess everyone's an expert on Parlé commissionings. Well, okay. So we've actually almost come to the end. So as a best practice, usually what even myself, what I do is I always use a local monitoring with headphones. This can actually be a temporary connection from the DSP itself, or you could even use a local recording software with a USB headphone. So this is what I typically use when commissioning. So Audacity is one of the free software available. You can actually just download and utilize that together with a Tessera Forte. So always, I think, listen to the room noise unprocessed, and have a feel of whether processing is necessary. Sometimes less is more. Process only when it is required. Conferencing with far end should sound as natural as possible. Heavy EQ might tend to result in unnatural tones, and, well, it will not sound natural to at the far end itself. So maintaining a 0 dB signal level across the whole audio processing would benefit most functions. And I think, aim to keep it at this level across the whole signal chain. Well, lastly, there is no substitute for proper gain structure. Always ensure that microphones have a proper gain structure to avoid, issues at the end of the signal chain. So during the life cycle of a project, Well, as a recap, it's always to take physical measurements of the room itself. Thereafter, take the acoustical measurements of the room. So use our cornerstone calculator to generate or validate a design. The tool can be found on Cornerstone design tools itself. So do make use of that. Thereafter, once you have all the information gathered, such as the physical measurements of the room and the acoustical measurements of the room, use all these and to configure the Parlé processing block. Importantly is to verify the performance through listening and adjustment, but remember to do adjustments sparingly and not to utilize heavy EQ so as to sound as natural as possible. And last but not least, Biamp makes success easy. We have the tools and the technology to simplify the design, installs, and commissions. So make use of those. So I have a question regards to monitoring from Audacity. Okay, so let me pull up. Let me see whether I can show you how I do it with Audacity. Um, so don't mind, I'm actually opening up my Audacity. Let me know if you can see my screen. Well, so for one, what I usually do is I connect Audacity to my Tessera Forte, and I will send the far end audio into my headset itself. So in this case, uh, I can hear the whole process as to from from the microphone with all the processing, how it will sound like at the end of the chain before it goes to the far end. And this is just one tool itself lah, that I use uh, in my commissions. Yep, I hope that answers your question. So with that, I've actually come to the end of uh, my webinar. Thank you for tuning in, and yep, be safe. I'll see you soon.